mean by physical junction electrical? What do you mean by electrical junction where current branches here? Now when I send a current I, I'm going to push a current I there. So this current I, so here it will branch out. Let it be I1, I1. Here let it be I2. So this current I1 further, it will divide I3 and I4. So here it will be I3 and this is I4. This I3 here, it will not branch. And this I2, it will not branch. So here actually I3 plus I4. So this should be equal to, so let me write I1 only. This is. So how much of current finally? The same current I. So you have to see that what current enters the network, that current should live. In that way, the current has to be divided. Now, the very first question you can ask here, like, look at this here, so like, why it is not branching? It's a junction, no? That this I3 can branch out here. So here, what is the method is? I'll go for so here I'll draw some line, that one. You can see the dotted line. Look at about this particular dotted line. Is it the current flows symmetrically? The circuit is it symmetric, and that particular symmetric line passes through a junction. So now when what is the idea now? There's like a theorem like this. We have almost around 300 or more than 300 different methods are there, of which in for our syllabus now we are putting around some 10 or 15 methods. More than 300, not one to few, more than 300 methods are there. So there's like a some sort of theorem what they have proposed here. When a symmetric line intersects a junction, then the junction is just a physical junction and it is not an electrical junction. What do you mean by electrical junction where current branches here? What do you mean by physical? As you are just putting the knot there, the current will not branch out. So then what to do now? So what to do now? So that particular what happened? The current doesn't branch out, so you redraw the circuit. So when we redraw the circuit, practically, sir, can we really work out as you take ammeters, current measuring instruments, then connect in various branches? No, you see like in fact what we are stating, no, that particular thing can be verified. So like that what happened, the practically they verified the most of the theorems, then they made a rule with that one. So there is no any I'm removing, you see that one, the junction what happened there, it is like this, huh? Like this what happened, what all they proposed, no, they verified practically and then they made a rule. Like this, there are around more than 250 rules is what uh, will come across in the electronic designing of circuits here. When we design a circuits, no, we just, if you know all these rules, it'll be much easier for you. So this was the junction, no, they're not in contact. So this is O, There's a point 2, no? I remove it. Now what happened? The current, in fact, it doesn't branches here. Now how do it appear? Simple series parallel. This 2R, 3R by 2. So what is the simplified circuit will be R, R. This is point A, this is point B. So what is this? This will be 2R, 2R by 3, 2R by 3 plus 2. So 8R by 3A, this is R, this is R, this is 8R by 3. So this is called as a junction removal. How to now few questions. What are things like, sir? How do you can say that? What do you mean by symmetric line? What do you mean by this symmetric line? Because we must get an idea, no? What do you mean by symmetric line? Symmetry with respect to what? Symmetry with respect to current distribution. Symmetry with respect to current distribution. By chance, if I make this 2R, no, then what happens? It will become really electrical junction. If I make it this 2R, then what happens? The current will in fact will branch at O. Then it will become electrical junction. It's only now a physical junction. How to identify a junction is only a physical junction? If a symmetric line intersects a junction, then the junction is only a physical junction. There's a rule. How to identify a symmetric line? Symmetry with respect to what? With respect to current distribution. So how do I can distribute current now? So you have to look at the resistor here. You can see that current I1, I3. How much of current entering the circuit here? No, this I1, it will enter. Then the same current I1 is leaving. I3, I3, I4, I4. So then is symmetry about this distribution of current about this vertical line, dotted line. Yes, it is. So I'll call this as symmetry. Symmetric line. See, what they did is there's no any hard and fast rule. They assumed a circuit, they assumed things, then they practically verified. And the practical outcome, they got the effective resistance according to this circuit. Then they made the rule. Getting the idea, no? So now you can't make your own rule. What happened? Provided you should verify it practically. Got the idea, no? If you verify it practically, that's fine. Then that become like a rule, that one. By chance, if I make 2R, no, then we can't simplify this network over. Now instead of this, like a here you make it this 2R. Is it a symmetric junction? No, definitely. Can you separate it? Next, the question comes, can we separate this one if this is 2R? This is, if you make this also 2R, then you can separate. You can remove it. Now it will become a only physical junction, but only when above is 2R, no, then you can't divide current I1 and I1, because you can see that the circuit is not similar here. Following this one, I1 dash, you have to write it. So then it will not become physical junction. Then it will not become only physical junction. Then sir, I'll make this 2R. Then will it be physical, only physical junction? No. The current here will be I1 and I1 dash. The current here will be I1 and I1 dash. No longer this only physical junction. Then if I make this 2R, then no longer this will be only physical junction. Okay, got this is something. So now symmetry, shall I tell you in for at your level, symmetry, it's all about just like a look at the network. Is it it's like a R and R, R and R, R by 2, R by 2. As we have a symmetry of distribution of resistance, then definitely the current will get distributed symmetrically. Then if a symmetric line intersects a junction, the junction is only a physical junction. So separate them. Make it like this here. Now, this part of circuit, simple series parallel, 2R, 2R by 3, 2R by 3 parallel plus 2. It'll be 8R by 3. No, this 8R by 3, 8R by 3. They are parallel. Then their effective is in parallel with 2R. Then we'll get RAB. Anybody value RAB?
4R by 5.
4R by 5. No, sir, I didn't like this. I can't think logically. What is alternative method? You find out the current, you connect a cell across this. You connect a cell. Measure the current. Then What is the net resistance seen by that? E by I, R equal to E by I. There's the last option available. There's the last option available. In definitely what happens when they give very complicated, So what earlier the engineers they did is like they connected a cell, they found out a current through the network. Then they know applied EMF. Then what is the net effective resistance R equal to E by I? Then they thought, okay, can we assume things like this? Then they found out resistance. So what they found out theoretically and practically it was matching. Then they made a rule. Got the idea? This is like, so these are some sort of theorems. If you look at the resistive networks, if you read some book, current electricity, they call it resistive theorems. They call that one. Like that, we have 300, not one, two, almost 300. Well, around 10 or 15, I'll discuss the time.